Well, hello everybody, and welcome to our webinar, Applying Artificial Intelligence to Achieve Revenue Growth. We have various attendees across the different time zones, so good morning and good afternoon and good evening to everybody that's taken the time to join us, so thank you. My name is Richard Blatcher from Pros, and I will be your host for today's webinar. You join this webinar as an audience member, and everybody is in listen-only mode. The webinar will be recorded and we will make it available after this session. If you're having any technical difficulties at all, then please use the chat box in your console, and of course we will attempt to get it fixed. After our three panelists, we have plenty of time for our panel to answer any questions that you may have. So again, please do use the console in your GoToWebinar panel and enter any questions that you may have. And then as your host, I will pass on those questions to the relevant member of our panel. All of you will receive a PDF version of this material as well as a recording of this session. So first of all, I have pleasure introducing our three speakers. Dr. Michael Wool is the Chief AI Strategist at Pros, where he helps companies survive and thrive in a modern digital economy via the use of big data, machine learning, and artificial intelligence. Prior to this, Wu served for a decade as chief scientist at Lithium, focusing on developing predictive and prescriptive algorithms to extract insights from social big data, and as a fellow at the Los Alamos National Lab conducting research in face recognition. His research spans many areas, including customer experience, CRM, online influence, artificial intelligence, and gamification, and has won him recognition as an influential leader by CRM magazine. Wu received both his PhD and triple major undergraduate degree in applied maths, physics, and molecular and cell biology from the biophysics program at the University of California at Berkeley. He speaks often at universities, conferences, and enterprises, and his experience and insights are accessible through two ebooks, The Science of Social and The Science of Social 2. Ruptesh is a management professional and technology enthusiast who enjoys helping manufacturing companies achieve their business goals by leveraging cloud technology, artificial intelligence, Internet of Things, machine learning, big data, and business applications. Ruptesh is a qualified mechanical engineer and MBA with 20 years of international experience with broad leadership experiences in leading technology and manufacturing organizations like Microsoft, Fujitsu, Tata Motors, and Jaguar Land Rover. At Microsoft, Ruptesh and his team help the largest UK headquartered enterprises in the manufacturing and resources segments to diagnose opportunities and challenges, identify performance improvements, and deliver change. Ruptesh is especially passionate about driving such sustainable change through technologies like artificial intelligence and the industrial Internet of Things. And our next panelist is Manish, who has more than 20 years experience in application and system software development and the architecting of enterprise distributed systems. He co-founded WebSim Technologies back in 1998 and also set up the India R&D operation of Storability, an enterprise storage management startup from Boston. Storability was eventually acquired by Sun Microsystems, after which Manish founded and led the India R&D of Blade Logic, helping build a highly scalable enterprise platform for server management in the data center. Blade Logic was acquired by BMC Software after a successful IPO, and Manish contributed to BMC's cloud management vision, laying the foundation for some of the early pioneering work on cloud resource management and provisioning. He is also the co-inventor of 2 patents in this area. Manish has a BE in mechanical engineering and a master's degree from Florida Atlantic University in Florida. So that's our eminent 3 panelists, and I would like to start the main part of this session. So I have pleasure in handing over to Dr. Wu for our first section. Over to you, Dr. Wu.
Thank you, Richard. So today I am obviously going to talk to you about AI and how it works. But before that, I just wanted to preface that the concept of AI is actually not new. And this, we thanks to the entertainment and Hollywood that we all seen movies with AI in it. However, this perspective of AI is actually very shallow and won't actually help business leverage its full potential. So in order to realize the full potential of AI, we have to understand a little bit about how it works, and that really requires us to step back a little bit to see how AI came about and where it actually came from. So, and to do this, we really need to understand a little bit about business, a little bit of the history of business analytics and business intelligence. And I will illustrate this history with a, toy example using data that we are all very familiar with, and these are basically stock trading data. And basically, when you have lots of data, the first thing you do is you basically compute summary statistics that summarizes data so that you don't have to look at every single data point. So these are what we call descriptive analytics. And if you do this for a while, you start to see some patterns in your data, and then you begin to build a model uh, for your data. The model also summarizes data too, but then having a model, the advantage is, of course, is that now you can extrapolate to regions where data don't exist yet. And in this case, it's the future. So this is when you actually move into what we call predictive analytics. And once you have that, an eye into the future, the advantage is now you can even start to tell people what to do. Okay, for example, this may be a good time to buy, and this may be a good time to sell, right? So then this is when you actually move into what we call prescriptive analytic, because you are actually prescribing actions for people to take in order to achieve some outcome. Okay, so a lot of people, a lot of you probably have a lot of familiarity with descriptive analytics because you all seen dashboards and reports all the time. But a lot of people have misunderstanding about predictive analytic and prescriptive analytics. So I'm just going to briefly talk about that. Predictive analytic is actually all about, estimating some variables. Basically, it's about using data that you have to estimate, to make an estimate of data that you don't have. So in the case of the forecasting, is really using data um, that you have, which is historical data, to make an estimate of the future data, right? So in this case, the simplest examples of predictive analytic is really a trend line. Okay, so this is actually in the forecasting, but there's actually many, I would say, predictive analytic that's actually not limited to the time domain. For example, even in sentiment analysis, right? You are basically using text to estimate people's uh, sentiment, opinions about a certain entity. You could even have an age predictor, right, using images, right, to actually predict, estimate people's kind of age and or infer their genders from their text that they write or the speech that they talk about. So all these are examples of predictive analytic, basically using data that you have to make an estimate or inference about data that you don't have. Now, the simplest prescriptive analytic is actually a GPS, okay? Because GPS, what it does is that you tell me where you want to go, and then the GPS will prescribe you a sequence of action, like, for example, turn left, turn right, and to get to the destination where you want to go, okay? So now, prescriptive analytic, even though it's all about prescribing a sequence of actions for you to take, right? What's underneath is what happens underneath is really all about optimization. Because think about, why does a GPS actually prescribe this route? Because there's actually infinite number of routes to get from this green dot to this red dot, right? You can actually go around the river. You could even go around the entire globe and come back to the other side, right? But the reason it prescribed this route, because it optimizes for the shortest distance, right? So early GPS actually optimizes for the shortest distance, but nowadays GPS actually are much smarter, so they actually will optimize for the shortest time. So therefore, sometimes it may actually prescribe you a different route. But the reason they prescribe you a certain action to take is because those action actually optimizes something. Okay. Now, there's actually many other, I would say, more general prescriptive analytic, just as there are general predictive analytic as well. And these are actually not limited to the prescription of route in the geospatial domain, right? You can actually prescribe business strategy. For example, this you may say, I want to get to 20% increase in my revenue. So that's actually where you want to get to. Okay. And if you have the data, then all the data that's necessary, then basically your prescriptive analytics could tell you, maybe you need to price 5% higher, and then you need to hire some more people, and all the sequence of action that you need to do in order to get there. Okay. So there's actually many other prescriptive analytic system in our life as well. For example, search engine, right? They are prescriptive analytic system because there's virtually infinite number of content out there for us to read, but it prescribes us a particular set that actually optimizes for relevance to our search query, right? Recommender system is also a prescriptive analytic as well because, obviously there's a virtually infinite number of movies or music that we could listen to or watch, right? But it prescribes us a particular set because those optimizes the similarity between the content and our preference. Okay, so now you know the history of business intelligence going from descriptive to predictive and then to prescriptive, right? So the question is, what comes next? Okay. Now to answer the question of what comes next, we have to understand what do these traditionally, what do these business intelligence tool play in business? And the role that they play is what we call a passive decision support role. Okay. And they're called passive because they help people make decision, but they actually don't make the decision for people. Okay. Because regardless of what the data suggests, right, human at the end of the day still makes decisions about what to do. Right, what human always have the right to have the power to do this, right? And this is actually for very good reason because traditionally regardless of what how much data you have and what model you, how sophisticated your model is, right? A model's output, right, the is actually no comparison to a human expert's intelligence or a human expert's knowledge, right? And but over time, this actually have changed quite a bit, right? Because over time, we know that our data volume had increased dramatically, right? And our understanding of model have also increased quite a bit, right? Gone from really simplistic model in statistics to some of this very complex model today, right? And when we actually feed this data into this model, right, the result that come out of it actually depends on three things, right? So obviously it depends on the quality of the data, right? If you have garbage going into the model, then what comes out is going to be garbage, right? So your model also influence the accuracy of these analytic results as well, right? If your model misses a component completely, then obviously results wouldn't be very good. And the last is actually CPU, right? You also need a lot of CPU cycle, computing power, in order to crunch these data out in any reasonable time. So now, this is a little bit of just history, right? I'm just going to go through this very quickly. So I just want to say that, like neural models such as neural network, we heard a lot about neural network today, but they're actually not new. We actually know about neural network since 1950s. Um, but what's limited back then is the fact that we actually don't have enough data, right? Even if we have data somewhere, the most of those data are actually not digitized, so they're actually not accessible to the computer so that we actually can't use them to fit the neural network. And also, we are also limited by computing power as well, right? Because we are obviously using vacuum tubes back then, right? But basically, over, I would say, the next few decades, right, is very interesting because um, everything increases. The data volume increases, our computing power increases, and even our knowledge about the model increases as well, right? But our knowledge about the models actually increases more or less linearly, whereas the computing power and data volume increases more, exponentially. And this is actually largely due to a very famous law called the Moore's law. I'm sure a lot of you have heard of that, right? That's why data volume and computing power increases so much faster than our knowledge in of the model, right? So by the time when we get to the about 2000s, right, we already have distributed computing. What that means is that we could actually virtually have infinite computing power. Basically we just have to distribute them across more and more computers, right? Because there's no limit to how many computers we can add to distributed computing system, right? Pretty much. And so basically this transform this computing constraint into an economic constraint. Whoever can buy the most computer, they are going to have the most computing power, right? And basically the next decade, basically now we also have GPU, but what's more important is that we also have big data, right? Big data basically lift the constraint on data volume, right? So now you can pretty much have all the data you want, right? So now there's basically no more constraint on data and computing power, right? So what that means is that we can data scientists like me, we could basically use a very sophisticated model. Pretty much we could use any model that we like to, right? We can even use model that mimics our brain, how our brain works. So all these deep neural network, deep learning, or recurrent neural network, these are basically statistical models that mimic how our brain function. That's it, you know. And deep neural network is just really just a neural network that has many, many layers. Deep learning is just a process of how that network actually learns, right? So now we have no limits in data computing power, and we can use very sophisticated model, right? So basically now the results of this analytic can become very, very accurate. Okay. Now the question is, what happened when a human always agree with the machine's prediction, right? Do humans really still need to have the final say about what to do? You know, um, I mean, some of you may say yes, but then if you do, basically, since you pretty much always agree with the machine, right? Basically, you would say yes, 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 I agree, I agree, I agree, pretty much every single time, right? And that's really not necessary, right? And moreover, today, I think machines can actually leverage data from multiple experts so that the machine's prediction is probably better than any single person, right? So in that case, human is really a redundant. It's really not necessary to have the human have the final say because that's really obviously redundant, right? So so this is actually the beginning of what I call artificial intelligence, right? Artificial intelligence is really the beginning of it is really just the automation of decision and proper execution of subsequent actions. Okay, so traditionally, right? Going from data to decision to action, that is a human's job, right? We decide what to do, and that's always what we do, right? But with AI, right, basically we are automating this, right? Going from data to decision to action is simply just like a process automation, right? Data is a driving decision, and decisions are driving action pretty much automatically, right? And we have this here today already because today we have obviously in algorithmic trading, right? Rather than telling you what stock to buy or what stock to sell and when, right? Or even showing you data, in the case of predictive analytics, showing you how the stock market will perform, which how each stock will perform tomorrow, right? Why don't you just trade for me, right? So today we have robo advisor that actually manages your portfolio, but you just simply have to tell them your risk tolerance, right? And we also have automated loan origination. Right? Basically, there's really no need to have a person check off all the checkbox, right? As if the person actually meets all the criteria, just give them the loan, right? Now, if we go back to the domain of the geospatial domain, right, of a GPS, right, rather than telling me go left, go right, or go straight to go home, right, just take me there, right? Now so this is what I say, it's really just the beginning of AI because now these AI can automate decisions that we make and actions that we take, right? But they're not very smart yet. Obviously the self-driving car is not legal yet, and we heard horrific stories about the self-driving car hitting people, right? Uh, so they're not very smart. So the question is, what makes AI smart? What gives AI its intelligence? Now, if you actually Google around and actually do a little bit of research yourself, you may actually find this image. A lot of people will say, "Oh, what makes AI smart is all this deep learning that's happened in I would say, in recent years." And deep learning is actually kind of machine learning, and machine learning is actually kind of AI, right? So this is actually a very popular image that's floating around the internet for quite some time. But unfortunately, it's actually not quite correct. Okay, it's a little bit misleading. It's not completely wrong, but it's not quite correct. Okay. Deep learning is in fact a kind of machine learning. However, machine learning is not a kind of AI. Okay, machine learning is actually used in every modern AI that I know. So it actually kind of makes sense to put machine learning inside it because machine learning is, think of it as almost like a part of AI, right? Because it's using AI, right? But the reason this image is actually very misleading is because I could just illustrate this with another example that's very familiar to you. Okay, for example, you would say that uh, V8 is actually a kind of engine. Okay, an engine is actually used in every car, right? So now if you look at this picture, it's very easy to misinterpret this picture that an engine is actually a kind of car, right? So the reason is because the VIN relationship between these two boundary is inconsistent. One of the VIN is actually a subset of one of the other VIN is actually VIN boundary it represents a part of, right? And that's inconsistency actually make this image actually very misleading. Okay, so it's not completely wrong, but you have to interpret it correctly. Okay, so let's take a look at what's a better picture that actually illustrate how AI actually work. Okay, so it all start with big data. Okay, now data scientists like me, we turn big data into a model, and we use a very powerful tool. Basically, that tool is called machine learning. We use machine learning to do this, to turn data into model, right? Now, machine learning here is really both a noun and also a verb, right? As a noun, is really just a bunch of algorithm, right? And I could fill out several more slides with very confusing names of algorithms. Now, keep in mind that deep learning here is actually, in fact, it is one kind of machine learning, right? As I said earlier, right? So now, what about as a verb? As a verb, uh, machine learning is really just a process of turning data into model, and that's what data scientists do, right? We basically uh, turn data into model depending on what data we have and what model we're trying to produce. We basically pick different algorithm to accomplish this. Okay, and once we have the model, if we feed it with new data, some analytic result will be the output of this model, and these results often lead to decisions that have to be made, which often involve in actions being taken, right? If you take those actions, they will have consequences. These are outcomes that need to be fed back into the system in order for the system to work well. Okay, so as I said earlier, human always make the final decision, right? Traditionally, that's always the case, right? And today, in most of the, I would say, digital world, actions can actually be automated by machine already. But in the physical world, a lot of those actions are still taken by human, and feedback are also traditionally collected by human as well via survey, right? And obviously, survey is very slow, so we're not going to get this real time feedback which enable the analytics to work well and course correct in real time, right? So the first thing we have to do is we have to track these outcome, these feedback automatically, right? So this we have to automate this, and this can already be done very easily in the digital world because all involved is writing some code to instrument some tracker, right? To track the outcome. And even in the physical world, this can be done fairly easily with all the IoT and sensor devices out there. And now, if the model is good enough, as I said earlier, if the model is this model here, if it's actually good enough, basically we can automate the decisions as well. Okay. Now, this decision can be automated, right? And only in the rare cases when human disagree with the machine, right? And basically human can still override, right? That's why there's this tiny sliver of yellow here still that indicates that humans still can make the decision, right? And in the near future, when everything is automated by robotics, right? Basically, all the action can be taken by automatic in the automatic fashion as well, right? But today, basically, in the digital world, everything can already be automated. All the action can be automated already. Okay, so now this feedback loop here has actually pretty much no human involvement, except only in the rare cases when humans disagree with machine, right? Now, this actually had two implications. One of the implications is that this loop can go very, very fast, okay? And the second implication is that because every component here is automated by machine, everything can be digitized and turned into data, right? And once we basically turn everything into data, we can actually feed these data back into our big data here, right? Basically now the data, we have new data coming in, so the data change. Now, if we feed this new data in addition to the old one into this machine learning process, right? Basically, now we have a way to update this model in the automated fashion, right? And typically, even though we could do this in a completely automated fashion, usually it's a good idea to do it semi-automated, so we have some human oversight. Okay, and if you use the system over and over again, basically this model will become a very, very good model of the process of going from decision to action to outcome, right? Your model will learn this process very well and be able to predict the outcome for every decision you make, right? And this is basically a very highly simplified architecture of pretty much all the AI out there, right? And as you can see, machine learning is actually a part of this AI system, right? It's used in AI, but it's actually not a kind of AI, okay? And so that's why I mentioned earlier that that image, you should not you take that, as it is, you have to interpret it carefully. Okay. Now, every time we use this system, basically the system gets smarter because, and this is basically the what we call the learning loop, because every time you use the system, right, you have new data, and then that new data basically goes through the machine learning process to update the model, so the model becomes a better model every time you use it, right? And basically, this is actually what makes AI smart, because once you have a good enough model, right, that can match a human expert's decision pretty much all the time, right? Then the learning loop is what's going to make the AI smarter and smarter every time you use it. Okay. Now, some of the implication that's pretty amazing about is that we've seen in the news that AlphaGo, this program, is able to beat the world champion in the game of Go, right? So um, and basically, this is pretty amazing because AlphaGo was actually never trained with the world champions play strategy, right? But they were actually trained with, professional Go player. They're good player, right? So, but now once AlphaGo is basically good enough to play a human player, they're a professional player, right? Even though they're nowhere near the world champion, Lee Sedol, right? Basically, we can actually make AlphaGo play against AlphaGo itself, right? Because now basically this is leveraging the fact that now that feedback loop can go very, very fast, that learning loop can go very, very fast, right? Because if you play a human, it takes you probably several hours to play a game, but if you actually play, let AlphaGo play against itself, you could basically play millions of games in a day, right? And the implication is that you could probably make all the mistake that a human could ever make in their entire lifetime and learn from it and never make those same mistake again, right? And that's actually how AlphaGo was able to beat the world champion. Okay, so hopefully by now you know a little bit about how AI work. And so the next thing is that we have to learn how to pick the right technology for your business. Okay, so a lot of people often ask me like, so what can AI do? As you can see, this is actually the wrong question to ask, right? Basically, AI can pretty much do everything that we can do as long as we could fully digitize the process, right? Now, the key here is that, fully digitize. We need to be able to have data for the entire process. Don't expect AI to kind of fill in a part of the process that you did not, digitize or did not, because it's not, you won't be able to do that, okay? You need to have the data of the entire process before you can use that data to train the AI to do whatever that we do. Okay. Now, because of this, there's also a lot of, I would say, applications of AI. There's actually thousands, probably tens of thousands of applications of AI, but there's actually four very important applications of AI that are very important right now in a lot of the industry. Uh, One is basically, I would say, these perceptual AIs, right? So these perceptual AIs are basically the chatbots and digital assistants, right? And we are very familiar with a lot of these, like Microsoft's Cortana, right? Siri, Alexa, and Google's Assistant, right? Even pros actually built one of perceptual AI called Monet ourselves. We actually use Microsoft's bot framework, the Lewis bot framework, to build this ourselves. So, so these perceptual AI, the biggest applications perceptual AI is in human-computer interactions. Okay, because obviously, if you have a machine that can understand you using your language and speak back to you in your language and see things as you do, right? Then of course these machines going to interact better with human, right? Okay, so that's perceptual AI, right? The next big applications is in the internet domain. And obviously, the internet generates lots of data, right? And the biggest, so this is actually very familiar to a lot of us already, right? This is the biggest application of the internet AI is basically recommender system, right? And Amazon and Netflix are some of the early pioneers of this. And this is actually evolved into what we call today a lot of the personalization engine because because once the machine is able to learn your preference, basically it could recommend better and better content for you. Right. And the next category of application, the big application is in the recent year is autonomous AI. So autonomous AI, the biggest application there is obviously the self-driving car, but obviously it has a lot of, I would say, applications in robotics, IoTs, and connected machines, right? Because it's all about machine talking to machine or parts of machine talking to other parts of the machine to resolve conflicts so they can actually function autonomously. Okay. So now, lastly, the last category is basically what we call business AI, right? So the biggest application of business AI is business decision and automation, and these tend to be very, very specific to the business domain. right? You see fraud detection here, algorithmic trading, right? And here you see also, medical aided, machine aided medical diagnosis. Right? Watson actually do a lot of these, right? And pros here is actually also one of these business AI, right? We actually automate the decision of pricing and opportunity to go after, right? So we tell you how what opportunity to go after and because and also like what price or because there's actually infinite number of price you could set, right? But you could, if you set it at a particular price that the pros recommend, then it optimizes your revenue. Okay. So now there's also a lot of hype out there as well because today every technology company wanted to say that they do AI, right? Because that's the hot topic for today, right? And technology company traditionally what they do is that they have some legacy business logic that solve and address some business problem and they package these logics up and sell it as a product, right? But today, what because everybody want to say they do AI, is a lot of these technology company would just put a perceptual AI on top of their business logic, right? And then they declare win. They say now our system, our product actually has AI in it and it's intelligent. Okay, now that's not a false claim, okay, because perceptual AI is indeed a kind of AI. However, if you understand the learning loop, right? If you understand the learning loop, think about how what it's going to do for you every time you use this perceptual AI, this system, right? Every time you use a system, this perceptual AI is going to actually understand you more and allow you to interact with the system even more. For example, this perceptual AI may learn your business jargon. You may even understand your accent, the way you talk, right? And so it really will allow you to interact with the system a lot better and understand you a lot better. But what's actually solving the business problem is still the same old business logic, right? That part actually hasn't changed at all. Okay. Now, the I'm not saying that these perceptual value don't have value, right? These perceptual AI don't have value. They certainly have value. The value of proposition is basically increased productivity for the employees, right? But instead, for example, instead of waiting in line for coffee, you could tell your digital assistant to set up a quick meeting, send a quick email, or even fetch you some data, right? But think about this. Fetching a data is just a query, right? You could execute that query, when you're back on your desk in your computer, right? But now you can actually tell your digital assistant to execute that query for you, right? Certainly increases your productivity because now you can work everywhere, but that query is the same query before, right? That you execute right in front of your desk. So that part hasn't really changed, or it won't actually help you solve the business problem any better, even though it does increase your productivity. Okay, now the true value of business AI is that now every time you use this business AI, it actually solve your business problem better. Okay, so Pros has a tool just as an illustrative example. Okay, called opportunity detection. These system basically this AI basically recommend opportunity for sales to go after, but based on what the sales actually accept and what opportunity they reject and what opportunity they're able to close. This AI is going to learn what's the more appropriate opportunity for this sales, right? In the future, it's going to recommend more appropriate opportunity for this sales, right? Maybe this sales take like to take on big deals that he cannot close, right? But then this AI is going to learn that and recommend more the opportunity that's actually right for him. Okay, so the value proposition of these business AI is days and nights different, right? Because every time you use it, you make a better and smarter decision to solve your business problem better and better every single time. Okay, now so what can these AI actually do for you? Okay, so I mean obviously AI can help you improve customer experience, right? And this is typically the domain of these perceptual AI, right? Because obviously if you have a machine that could understand and human and interact with you like a human, right? Then people is going to have a lot better customer experience. And also internet AI can improve customer experience as well because now with, as you remember, internet AI, a lot of it actually, the biggest application is in personalization engine. If you have a machine that understands your preference, right, then obviously it can actually improve your customer experience a lot. Now, these AI can also increase your the business efficiency as well, right? So you've seen earlier, right, perceptual AI can increase productivity. That also increase business efficiency, right, operation efficiency. You can also have autonomous AI increase your efficiency as well, because autonomous AI simply, these are basically robots that can function by themselves, right? So of course, their performance don't degrade very quickly, right, as humans do. right? They don't need as much sleep, right? So they can actually increase efficiency that way as well, right? There's some business AI that's designed specifically to increase efficiency, but most of them, there are not that many of them out there. And finally, I will have to say that AI, one of the most important and exciting area is that AI actually can help you grow your revenue. And that's actually the domain of business AI. Okay. And Pro has been an example of that. But in later on, you will actually hear from Rutesh about how, these AI can help you grow revenue in the manufacturing domain. So with that, I'm actually going to hand it over to Ruptesh to tell you more about how um, you can use AI to grow revenue in the manufacturing space.
Thank you, Michael. That I must say was a fascinating talk on AI. Hello, everyone, and I'm going to speak to you about AI in manufacturing and the industrial sector. So the big question is why now? Why are we speaking about AI now? What is different in AI now? Especially as Michael, he told all of us that AI has really been around since more than 60 years. Well, the reason behind this is the advancements in AI. AI needs four fundamental bedrocks for it to thrive. And these four fundamental bedrocks are it needs a whole lot of data. And now with big data, with millions and millions of devices, processes, etc., connected to the internet, we have data like no time before. And on top of this data, you overlay logic. And this logic should go beyond those three or four dimensions which typically humans are capable of. And with things like deep learning and neural nets, we are able to today put thousands and actually millions of dimensions on a single logic platform and draw conclusions for that. So, because of these two big advancements, enabled by technology like the ability to call on cloud compute just anywhere, anytime, this is why AI has come on its own today. And the impact of this, we think, is going to be substantial in the manufacturing and the industrial sector. We've done some research with some of the leading consulting bodies in this world, and our estimate is that over and above normal business, manufacturing and industrial sector should be around 40 billion of estimated additional revenue in the next 3 years. Now that is massive. And when we've gone about speaking to enterprises, almost 85% of enterprises in this sector have told that they are going to be using some sort of AI by 2020. So the AI transformation story, uh, is it really real? Is AI real? And is it delivering anything? And if anything, is it delivering anything in the enterprise sector, in manufacturing and in industrial? Well, it certainly is. Uh, From Microsoft, we believe that there are three core scenarios that our customers are using today to transform their businesses with AI. And these three core scenarios are around digital agents. 95% of customer interactions would be powered by AI bots by 2025. So really taking off any sort of ambiguity in this moments of truth in customer interactions. The second is intelligent apps. We think that business applications would have AI infused on them just to increase their ingenuity, enhance and augment the way they can perform. And again, by speaking to many of these enterprises, we believe that 75% of them would be adopting this. And finally, in terms of the business processes, which form almost the fundamental bedrock on which industrial is based, um, while speaking to enterprises, they said that they would re-engineer business processes on AI platforms to make them much more productive. And 85% said that by 2020, at least one of their critical processes would have AI embedded in it. So if this is what AI is going to do to the manufacturing and industrial sector, what is Microsoft's position about it? And I'm sure you're all keen to understand this. Well, our strategy here is to build a best-in-class platforms and productivity layer for an intelligent cloud and an intelligent edge infused with artificial intelligence. So we are essentially seeing ourselves as that platform player, which is going to make it all real for our partners like Pros and Icertis and for customers by giving them those fundamental rocks required to make AI real. So what are those rocks? So these rocks are essentially three pieces for us as Microsoft. We believe that we'll provide the most comprehensive set of most comprehensive platform to really enable this, and this would be in terms of the Azure AI services, the Azure infrastructure, and the tools required to really build on AI. To delve a little more on this, with AI services, we are saying that we are going to infuse pre-built AI services, which we call as cognitive services, all the way to custom AI, which you could do through things like machine learning and conversational AI with our bot framework. So we'll have ready to build in almost modular AI packages right there for you to pull on and have those great solutions which could transform business. The other thing is this would all be overlaid on a very robust infrastructure. And our infrastructure has bits like the Cosmos DB, one of the most powerful geographically dispersed database systems in the world, and all up to edge computing. So that's the kind of infrastructure which has been embedded in our platform, and the set of tools which would make it real. So every tools we had in terms of the Visual Studio and etc. would all be embedded with AI. And the position which Microsoft is really taking here is to keep everything in an open source environment, so that irrespective of whichever platform you want to play, our tools will work. And that is really the position we take. And as far as we know, we are the only platform player who's going to give you this end-to-end solution in the platform across the globe. But we are not only giving you a platform, we are going beyond it. We think we have some deeply entrenched products in our Office products and our Dynamics 365, etc. What we're doing is we are infusing a lot of intelligence into all of this. So there's AI in all of our end products which are coming to you as well. And together with our tools, which are AI infused, which are with our robust infrastructure and our products, we think we are in a fundamentally strong position to help transform your businesses. We think these three pieces together, they can transform the various value chunks within your value chain. And if I'm to look at the value chunks which are really critical in a typical manufacturing organization, it's all about design and engineering, and then optimizing a supply chain and the factory of the future, and really selling products as a service. And these are the big bet areas where we think AI infused through our partners and the kind of solutions that our customers give would be great. Just to pull out an AI in the factory of the future, we think that it would be factory assistants, cobots, and a predictive and cognitive, solution within quality inspections, assurance, etc., which would be driving, almost transforming an isolated plant into a connected factory of the future. Similarly, in things like products, we don't think it's really going to be too much about tangible products anymore. Products would need to be servitized, which would then lead to an additional line of revenue. And with things like service bots and connected field service, guided service workflows, etc., we think the time has come for most manufacturing businesses to transform and go a step ahead, and making that, the departments which up until now used to be just cost centers like customer service into a profit center. Finally, also supply chain. We've done quite a bit of research, and it comes out from most manufacturers that this is one area which needs a lot of attention. A transformed supply chain can do massive benefits in terms of the cost downs and the efficiencies that it could build in. Today, lots of costs are really hidden within all of this. And just through AI, if we make this entire supply chain, if you can track it and make it transparent, if we can optimize inventory, if we can draw those connections between sales and operations for the right things to be produced at the right time, and most importantly, there are hundreds of players around this, both upstream and downstream. So there are the suppliers, and there are the distributors, the traders, etc., who work with lots and lots of contracts. If we can, almost manage this one area in a great way, we should only be driving in efficiencies and cost savings and opportunities here. And to really elaborate on this and speak a little more on this, I would now hand over to my friend Munish. a little more detail. Thank you.
Thank you, Ruptesh. And I think such a great foundation overall. Michael kind of talked about what AI means in the real world. And Ruptesh gave an example of, hey, Microsoft has the platform, the compute, and something that can actually make AI real. What I'm going to talk about is how, in the world of contract management, we are applying AI to actually give specific business benefits and increase revenue when it comes to managing your contracts. But before that, let me set up some uh, basis in terms of how we think at iService about how this business world is changing. Everybody knows the business world is changing. Commerce is growing more complex and more interconnected. All of you must have seen these changes come in your businesses. Changing customer expectations, supply chains are very dynamic. Things change every minute, every hour, every day, every week. There's rapidly evolving competition. There's changing regulatory risks. If you think about the GDPR, if you think about Brexit, if you think about all the data privacy rules and the compliances, it's just getting more and more complex. But at the same time, business really needs to be agile. In this changing world, leading companies are really embracing these changes to avoid getting left behind. The trick is, how do you kind of make sure that you leverage these challenges to your advantage? And I'm going to talk about two examples, two of our customers. Daimler is transforming their relationships with over 400,000 suppliers worldwide in response to new competition. You take another example in the manufacturing area, BASF. It's the largest chemical manufacturing company in the world. And to keep growing its over $64 billion in sales, BASF is reimagining its relationships with its customers in almost every country and every industry in the world. And how do these companies actually tackle this problem? And what do these leading companies have in common that they can actually transform their business and be competitive and agile? What they're doing is they're transforming their commercial relationships into strategic advantages. So the relationships with their suppliers, customers, partners, even their employees, they're taking those relationships and they're changing them into strategic advantages so that business can be accelerated. At the same time, you can be protected against risk, and also all the relationships you have can be optimized so you can maximize revenue. And we are trusted by the world's top companies. It's a small cross-section of some of our customers. But what is important, apart from the Fortune 500 list here, including Microsoft, is what you see at the bottom is 2+ million users, 5+ million contracts under management, more than $500 billion in contract value. That goes back to Michael's point that if you want to really have a business use case and apply business AI to a business use case, you really need data. And that data actually comes through a repository, probably the largest repository in the world in terms of 5+ million contracts. And that we can use and are using to bring contracts to life. And if you think about that, Michael also alluded to this, that if you want to really apply AI in a business context, your whole business process has to be digitized. And this is the first time in history, really, contracts are being digitized, allowing enterprises to fully reimagine contract management. And by being digitized, not just converting paper contracts to PDFs, but also looking inside the contracts, looking at what clauses they contain, what risks they contain, what are the obligations in those contracts. So you're actually now looking at data that was not previously available at scale, millions of contracts, and then you can look at, hey, now if I have this data, and if I apply some of the technology that Michael talked about on the platform that Ruptesh talked about, you can actually do some magic. And AI is really key to understanding the terabytes of unstructured data in contracts, understanding that can really transform the foundation of commerce. And that is because we have more than 20 terabytes of contracting data. No human can actually analyze that efficiently. But if you use these tools and you use them to learn, you can actually get to the business decisions and the automation that you need in making sure that your business processes are more efficient. And you can actually apply prescriptive analytics when you're taking those decisions. So let's look at how does AI help in the context of a contract. So if you think about how commerce works on rules, for example, how much will I pay? When will I make that payment? How much will I get in terms of payment? When will I get it? What will I need to do to pay or to get paid? All of that is actually always in terms of rules. Whether you're hiring a person or you're acquiring a company, there's a contract behind it. The contract specifies those rules, and commerce actually works on those rules. The contract is a one single place that actually enshrines those rules in an enterprise. Think about buy side contracts. If you're buying something, you're selling something, you're leasing something, you're employing someone, you're looking at compliance, anything that really has a contract behind it. And those contracts actually tell the organization how commerce should be conducted. And now, if you think about that, violating these rules can have very adverse consequences. If you actually use those rules to your advantage, and if you interpret them correctly, especially intelligently, then those rules can actually accelerate revenue growth. It can actually give you specific advantages in business scenarios which occur every day. And AI has that power to transform commerce if it is applied right. It can make contracting faster. It can tell you what is and what is not in your contract, so you can make sure that you understand the risks and prepare for them for the risk mitigation. It will also tell you where you should focus and where is your revenue hidden. So technology can actually really impact how commerce is actually conducted in large organizations, especially when you think about when contracts are negotiated and after those are executed, all the transactions that happen in across the systems, including ERP systems, actually follow the rules that are written down in those contracts. So if you can apply the intelligence that Michael talked about, you can actually make sure that these decisions in your everyday business processes that are backed by these rules enshrined in your contracts can actually drive revenue as well as increase customer satisfaction as well as make a business more competitive. And essentially, if we can make that AI that is infused in the platform, like we do in the Icertis contract management platform, or like Pros does when it comes to pricing, for example, AI that is always there to help, stepping in when you need something, preventing you from making mistakes, improving the way you work, you actually have the chance to transform your business from the ground up because you have the data now, you have the technology to learn from that data, and then you have a platform that can actually send the capability of taking decisions, the ability to take automated decisions, and to take the actions that follow and complete the feedback loop so you can do your business better. And that was, one example of how AI can actually look from a contracting perspective, can really help transform business. With that, I'll hand it back to Richard.
Thank you, Manish, and thank you to all of our panelists and presentations. And I'd like to use the last few minutes just to handle some questions that we've had in from our audience. So let me start with the first question. So Michael, I will start this one for you. So the question that we've had from the audience is whether you've observed any particular maturity path when looking at how business AI has and is being adopted by organizations.
Sure, I think there's certainly a path, but I don't think there is actually a single path. There's actually many different paths going to adopt this AI. I think one of the most common one has been really, it's the buzzword that's been floating around in the recent year as well, is digital transformation. Okay, that's typically where a lot of companies start because, as you now know, AI requires data in order for you require digitization of all the data, right? So all this data can be used to train the AI to be intelligent. Otherwise, you end up with an AI that's actually, not very smart, and people don't want to use it. And at the end, no one is actually realizing any value from it. So, I would say first step of digital transformation is digitization. I think that's certainly what both I think Monish and Rupesh had mentioned a little bit about that, right? So you need to get the data into from the physical world, whether from paper or something, into the digital world, so that these machine learning algorithm can take advantage of it and train your AI system. So I think that would be a good kind of first starting point. Keep in mind that there's actually many different starting points, but this is actually a very common one for a lot of companies I've seen.
Yeah. So thank you, Mike. And I think, Ruptesh, just evolving from that question, which kind of feeds into what Michael's just covered, and another one of the questions that came through is when you're looking to integrate this approach into the business, and you're in the manufacturing and the resource space, where would you recommend that an organization or somebody on one of our attendees should start? Where should somebody look at starting?
Yeah, this is a question which is very frequently put forward to us, and our suggestion always is that one should go on a step-by-step basis, and we almost see this as an evolution, AI as the final evolution process in creating an hyper-connected world. So like Michael was saying, AI really thrives when you have enough of data out there to make those for the logic layers to work in the best way in which they can. So really, the first steps should be to almost do an Pareto analysis of your important resource estates. In the manufacturing estate sector, it could be things like your installed base of machines, your resources of people, etc., and slowly try and connect all of this onto onto a platform where you can start getting all of this data together. And then you should build on it and then include the larger ecosystem as you grow on it. So it's really about start connecting, and you would immediately start seeing at least 5 to 10% efficiencies in your business when you've connected on a good way with industrial IoT of things, and with data available in systems, processes, etc. It is at that stage when we can pull everything together and start making logic in some of your processes and some of your applications and digital agents. So really, my suggestion to everybody is please get into a connected environment with something as powerful as Azure Cloud, etc. But that should really be the first step, digitized by getting connected.
Got it. Thank you, Ruptesh. So that's great advice, particularly as certainly data indicates that the majority of the attendees on this call have or are looking to embark on some form of digital transformation. Now, in the last minute, Manish, a little bit more of an apologies if you could keep it brief, because we have a limited amount of time. But a legal question for you is that how should our audience members, lawyers, or legal department look at AI when you've been talking about the realm of contracts? There's a lot of legal implications with the AI. So any quick advice you have?
Well, absolutely. I think one of the things that has happened over the years is this is probably the first time in human history, and I'm making a bold statement here, that technology seems to be at least advanced in terms of business problems. Typically, technology evolved because a business problem needed a solution. People are now trying to find problems to fit the technology that is available. And if you think about that in the context of contracts as well, I think one of the things that we have to look at first, in my opinion, and in general, what you're seeing in all our Fortune 1000 customers as well, is that you have to first identify a business problem to solve. It's no different in the contracting world. You cannot actually look at hey, I have AI now, where do I use it? Can I make my lawyer smarter or my paralegals redundant? I don't think that's the question to ask. The right question to ask is, here's the business outcome I'm looking at. Maybe I want to increase my revenues by 10%, or I have to make sure my contracting process goes from 30 days to 5 days, or I can sell a car immediately by making sure that the loan application happens in 5 minutes. I think that's the mindset to approach, and that's how you look at the technology and the platform selection as well as the tools. But absolutely, digitization is critical. I think that's the place to start as well. But you really have to focus on the business problem as opposed to looking at technology first.
Got it. Thank you, Manish. And thank you to all of our presenters and to our attendees today. That concludes our webinar, and we will be sending out, as I mentioned in our introduction, a recording of the webinar and the material that we presented. So thank you, everybody, for your attendance this afternoon.
Thank you.
Thank you.
Thank you.